not a rocket. A real aircraft, built in 1950s France, designed to take off vertically, standing straight up on its tail, then rotate forward into normal flight once airborne. The pilot sat inside a circular tube fuselage pointed directly at the sky. To land, they had to descend backwards, completely blind to the ground below, navigating by instruments alone. The idea came from a real Cold War fear that runways would be the first thing destroyed in any major war. A fighter that needed no runway at all was a serious military advantage. It flew multiple test flights, hovering, transitioning between modes. Then in 1959, during a transition maneuver, it lost control and went down. The pilot survived. The Coleoptère wasn't a bad idea. It was a correct idea built before the automation existed to make it safe. The Lackner HZ-1 Aerocycle. The U.S. Army wanted a flying machine so simple that any soldier could learn it in 15 minutes. What they built was a pair of counter-rotating rotor blades on a small platform, with the pilot standing directly on top, holding two handles completely exposed. No cockpit, no seat. No protection from the blades spinning inches below their feet. At low altitude, it was manageable. The pilot's natural balance acted as a stabilizer. The Army was encouraged. Above a few feet, it became a different machine entirely. Any shift in weight, a slight lean, a gust of wind, triggered oscillations the rider couldn't correct fast enough. After enough terrifying test flights, the program was canceled and quietly filed away. The Army wanted something a soldier could fly in 15 minutes. What they got was something that could kill a soldier in 15 seconds. Lockheed Ringwing. Aircraft wings generate most of their drag at the tips, where high-pressure air beneath rolls up into the low-pressure zone above, creating vortices that bleed energy constantly. In the 1950s, Lockheed engineers proposed a clean solution: eliminate the wingtips entirely by bending the wing into a full circle surrounding the fuselage. The Ringwing looked exactly like what it sounds, a plane sitting inside a giant hoop. It flew, but the moment it became airborne, stability problems appeared that the wind tunnel models hadn't predicted. Controlling it required constant input. The project was shelved. The insight wasn't wrong, though. Those same wingtip vortices are why modern commercial jets have the upturned tips you see today, called winglets. Lockheed was solving the right problem. The ring was just the wrong shape to do it. Airbus A300-600 ST Beluga. Airbus builds its aircraft in pieces across 4 countries. Wings in the UK, fuselage sections in Germany, tail in Spain, and everything has to meet in France for final assembly. As the jets got larger, the components grew too big for any existing cargo aircraft to carry. A full A330 wing is over 30 meters long. Nothing could move it. The Beluga looks like someone inflated a normal jet with a bicycle pump and refused to stop. The upper fuselage is an enormous pressurized dome, wide enough to swallow an entire aircraft fuselage in one load. It looks aerodynamically impossible. Pilots who flew it said it handled fine. It worked so well that in 2018 Airbus built a bigger version, the Beluga XL, to keep up with demand. Both are still operating today. The strangest looking production aircraft ever built turned out to be too useful to retire. Vought V173. Between 1942 and 1947, residents near the Vought test facility in Connecticut reported dozens of UFO sightings. Descriptions were consistent: a flat, disc-shaped object moving slowly at low altitude, making an unusual sound. The military received the reports and said nothing. The disc was the V173, a real aircraft, just one nobody outside the classified program knew existed. Its circular body generated lift across the entire surface, not just the wings, meaning it could fly at speeds as low as 35 miles per hour without stalling. Test pilots called it nearly impossible to stall. Charles Lindbergh flew it personally and came away impressed. The Navy wanted it as a carrier fighter for exactly that low-speed performance. Then jet engines arrived and made the entire propeller fighter category obsolete almost overnight. The V173 prototype still exists. It sits in storage at the Smithsonian, the only aircraft in history responsible for more UFO reports than any other. Bloemfontein B Vi 141. Every aircraft ever built is symmetrical. Asymmetric aircraft create unequal forces that roll and yaw the plane continuously. Compensating for it burns fuel and exhausts the crew. Symmetry isn't tradition, it's physics. Richard Vogt designed the BV-141 asymmetrically anyway. The German military needed a reconnaissance aircraft with unobstructed sightlines in every direction. In a conventional fuselage, the engine and nose block the crew's view. Vogt's solution was to move the crew out entirely. One side of the aircraft held the engine and structure. The other carried a large all-glass observation pod. Hanging off the wing, giving the crew a panoramic view no conventional aircraft could match. 3 prototypes flew, all handled normally. Pilots reported no unusual behavior. The program was canceled anyway, not because it failed, but because Germany already had other reconnaissance aircraft in production and couldn't justify adding another to the schedule. Vogt had solved the problem. Nobody needed the solution anymore. Caproni CA-60 Noviplano. In 1919, Italian aviation pioneer Gianni Caproni asked a question that seemed logical at the time. If one wing generates lift, do more wings generate more? His answer was 9. The CA-60 was a flying boat with 9 wings in 3 rows, 8 engines, and enough space in the hull that the construction crew used it as a workshop while building it. Caproni's goal was 100 passengers across the Atlantic, at a time when the Atlantic had only been crossed by air once, by a military bomber with a crew of 2. On March 4, 1921, it lifted off Lake Maggiore in northern Italy. It flew for approximately 60 seconds. Then the nose pitched up, it stalled, and came down hard onto the water. 9 wings, 8 engines, 2 years of work. Gone in under a minute. Caproni asked permission to rebuild it. He was refused. Some of the wreckage is still at the bottom of that lake. Northrop XP-79B. Most fighter aircraft are armed with guns. The XP-79 had none. Its weapon was itself. Jack Northrop designed it to destroy enemy bombers by flying directly into them. Its reinforced magnesium wings acting as blades to slice through a bomber's tail or wing at high speed. Because that kind of impact generates forces of 9 to 12 G, enough to knock a seated pilot unconscious, the cockpit was cut into the wing itself, with the pilot lying flat on their stomach, face forward. The prone position keeps blood in the brain under high G load. Northrop was designing around the physical reality of what the pilot would feel during the collisions they were supposed to cause. Development took 3 years. World War II ended on September 2, 1945. The XP-79B flew for the first time on September 12th, 10 days after the last surrender was signed, with no enemy bombers left to ram. 15 minutes into that flight, test pilot Harry Crosby lost control at 10,000 feet. He attempted to bail out and was struck by the aircraft as he left. He was killed before he reached the ground. The XP-79B hit the desert and caught fire. Rescue crews arrived with water hoses to case not and made it worse. Magnesium burns hotter when water is applied. 1 aircraft built, 1 flight, 15 minutes. The war it was designed for was already over. Stipa Caproni. This aircraft looked like a flying barrel. That is not an exaggeration. The entire fuselage was a short, fat, hollow tube with a propeller mounted inside it and a pilot sitting on top. From any angle, it looked less like an aircraft and more like industrial drainage pipe that had been given wings. Luigi Stipa's theory was that channeling a propeller through a narrowing tube compresses the air and produces more thrust than the same propeller in open air. He was right. The aircraft flew, it was stable, and the thrust figures matched the calculations. What Stipa had built, without fully realizing it, was the first working demonstration of the ducted fan, the same principle that sits inside every commercial jet engine operating today. The fan at the front, the compression stages in the middle, the thrust from the rear, all of it traces back to what this barrel-shaped biplane proved was possible in 1932. He accidentally discovered the foundation of modern jet propulsion. It flew at the speed of a bicycle. Both things are true. Lockheed XF-V1. The Cold War created a specific problem. In a full-scale conflict, enemy missiles would destroy air bases in the opening minutes. Any fighter that needed a runway was vulnerable to being wiped out before it could even take off. The Navy wanted a combat aircraft that could operate from anywhere. A ship deck, a field, a clearing, with no ground infrastructure at all. The XF-V1 was a tail-sitter. It launched straight up like a rocket, transitioned into horizontal flight, fought, then came back and descended tail first to land. To do that last part, the pilot had to look over their shoulder at the ground coming up beneath them, judge their speed and descent rate, and set down a jet aircraft moving backwards, in a crosswind, possibly over a moving ship deck. Test pilots managed the horizontal flight. The vertical landing was a different matter, considered by most who attempted it to be at the absolute edge of what a human could reliably do without dying. There was a second problem the test program couldn't hide. The engine wasn't powerful enough for true vertical takeoff. Every single test flight started with a conventional rolling takeoff on a runway, which meant it was doing exactly what every other aircraft did, defeating the entire purpose of the design. Cancelled in 1955. The right answer to the right question, built just before the engineering existed to make it work.